Hi, welcome back to Mini Rust in Rust. We are writing a little Rust-like language in Rust. It's going to be interpreted. What we're doing at the moment is we're allowing this example to drive us. So we've got this test which just says when you try and calculate the factorial of factorial of 3, you should get the answer 6. And we're getting through it. So like we had to make... I had to allow this mute keyword to say variables are mutable. We had to allow mutations to actually happen. We had to deal with a while loop and what it looks like. And what we just finished up with is type checking this whole thing. Now we've got a few to-dos in our type checking code. So if you're here for the type checking, you're going to have to wait a bit longer because we skipped over that. It was too hard. Here we're just like making the code execute. Stuff like that. So type checking is kind of out of the way. And now we have to see how far we can get through actually mutating these variables and getting an answer out at the end. I don't know how far we'll get, but let's see. So I've unignored the test. Let's run our tests. And we get an error in our evaluator at line 72. So let's open up our evaluator. And we can see that when we're evaluating a while loop, we don't currently have any code to actually do that at all. So this is probably really interesting stuff, right? So this has to do the code we're going to write that goes in here is going to do the kind of actual work of if this expression, evaluate this expression. If this expression comes out as true, then run these statements. And then evaluate this expression again and run these statements again if it continues to be true and so on. So, you know, pretty exciting stuff. I mean, as exciting as it's going to get in this series, I reckon. So we're going to imagine that there is a method called eval while. And we're going to pass in these two things. Maybe we're going to dereference them before we pass them in, not sure. And I noticed this. That looks like a bit of a hack to me. So let's not copy that. Let's copy something like assignment or operation where we just pass the stuff through and evaluate it. And I think we're going to dereference both these things. Let's make them actually exist. All right, so imagine a method exists called eval while. And let's make it exist, and we'll put it, after the assignment's fine. It takes in a type syntax tree, which is the expression, and a type syntax tree, which is the block. And I guess we want to do just something really, well, hold on. Where's my test discipline gone? I realized I haven't really written tests for the type checking code that I wrote last time. So bad me. But on the other hand, it didn't really do anything very much. So we might leave that until we actually do some type checking in that code. But we're definitely going to need some testing for evaluating a while loop. So let's try and figure out how these tests work. So yeah, we've got a test for like evaluating numbers, evaluating addition. I feel like testing a while loop is going to be a little bit difficult, but we'll do our best. Okay, so we'll write a test called. I guess the first thing will be if we never get into the while loop. So that will be a while loop whose condition is false, does not evaluate block, something like that. I wish I could write things nicer. All right, so what's that going to look like? We're going to say while I mean, we're going to say while false. And then how are we going to check that this doesn't execute? I feel like we need mutable variables to do any of this. And of course, in order to have mutable variables, we're going to need some tests for mutation of variables. Like we could do some kind of panic, but we haven't implemented panics or anything like that. So I guess the best way to do this is going to be to say let mute x equals 0, while false x equals 1. Or we're going to have to say plus equals 1 because we haven't implemented x equals 1. And then the answer to this whole block is going to be x. And the value of this should be a 0. Now I know actually we currently are going to probably return a longer list than just 1 because I feel like we're returning one value for each statement at the moment, but that's something we're going to need to fix to make this work. So that test definitely going to fail. So let's go back to our examples and ignore this test because that one's still failing. But now our new test should fail too. Oh no, we haven't. All right, we've started writing code, so we got compiler errors before we wanted them. All right, so let's just panic here with a to do. Now, when we run it, our new test fails because that's not what I was expecting. I think our parsing of while loops is not good enough for that code to actually work. We need to say while 0 is greater, let's say while 1 is greater than 20, right? Something like that. Okay, I think that is in. Okay, no, something else up here. Oh, no, we don't have a greater than yet. What about greater than or equal? How about that? Oh, no, do we not have that either? You see, we've written barely any of this language, and it's starting to really bite us when we try and use it to do stuff. Yeah, there we go. So here we panicked at not yet implemented. Let's have a look at line 160. Yeah, we panicked exactly at the code we've just been writing. So that basically means we need to ignore this test for a second. Well, not for a second, probably for a while. I think we're further away from this than I was expecting, because the first thing we need to do is be able to mutate things, which is needed here. So first of all, I think we should check whether a mutable variable just evaluates at its value. So let's check. So we've got evaluating an integer gives the correct integer. We've got an assignment sets a variable value. So that's basically saying when you set x to be 3, add 4 to it, you should get back 7. So we want something similar to that, which is a mutable assignment. Because we haven't actually checked that the let mute does the same as let. So let's do that. A mutable assignment sets a variable value. Now, here's the to-do that I was talking about before. It returns a list of things and it shouldn't. So a mutable assignment, let's say, now we always change our numbers. So let's say x is 13. And then let's just ask for x on its own, just to be a little bit different. Now here, the value should be, this 0 is just like kind of for a unit. That's we return an i32 bracket 0 from a statement. It should be a returning unit, but anyway. So this is particularly weird, but we can ignore that stuff and just say if we let x be 13 and then ask for x, we should get back 13. So that test should pass. It does. Excellent. So now let's check that mutating a variable changes its value. So mutating a variable changes its value. So let's change the variable name as well. That's a thing we should have done before. Let's call it 13, and then let's modify it by multiplying it by 2, and then let's ask for it. And while we're here, so this should return 26, right? And I guess for now we're going to live with the fact that we get multiple things, but we should fix that to do really soon because it's getting annoying. And while we're here, let's oh no, it's in the same test because we're really testing the same kind of thing. If we add 2 to it, we should get back 15. Now these tests should fail, or this test. It fails because something is not implemented, and I guess the thing that's not implemented is mutation. Makes sense. So let's imagine that we have a method called mutation, which takes in the stuff we've just been given, like so. And now we've imagined it exists, let's make it exist. This is going to go before a while for sure, because it's kind of more primitive in some sense. And we can lose that. We'll bring in that so that we can refer to a mutation token. Okay, so what do we actually do? What we need to do is update the thing in the environment to be different based on mutation tokens. So I guess it's going to be, we're going to find a new value by matching on the mutation token. Once we've got the new value, we're going to do similar to this. Well, I'm looking at the above, the assignment expression here. Does something very similar, which changes the environment to say the symbol, this symbol in this environment, which is really silly and wrong. It should return unit. And yeah, okay, it's just warning us that we haven't actually done anything yet. Now, mutation token. Oh, okay. Mutation token must have some kind of type or something, right? Kind, yeah. That's what I wanted to match on. And there's currently only 2 mutation kinds so far. There's plus equals and times equals. And what is inside that? Oh, just the string plus equals, which we don't need. All right, so we're going to not worry about that and just do... New value is going to be the old value plus expression. So I guess we need to evaluate expression and then check its type. Well, no, hold on. The type should already have been checked. So this is interesting. Yeah, do whatever plus equals means for the type of the symbol that we're looking up. So first thing I guess we've got to do is get the old value out of the environment. So we've got this thing called an environment, which is basically all the variables that have been set. We get it out like so. Does get take a symbol? Takes a str. Okay. So we'll pass in the name of the symbol. Now we have an old value, which is itself. I guess we're going to need to fail if that doesn't exist. That makes sense. So now old value is of type value. And based on the type of old value and new value, we're going to do something. So I guess we want to say something like match on old value, comma new value, and do something based on what type they are. Oh no, we don't have new value yet. So, what I mean is like expression. So we're going to evaluate the expression, which is whatever was on the right hand side of our plus equals or times equal. We're going to call this, let's call this new value as well. And yeah, there we go. So there's lots of different types of thing that these things might be. Why are you complaining? Mutation should take a mutable reference to self, same as all these other things, because it might change the environment. Okay, so we've been told it's a plus equals, and the two values are both I32s. So, is this okay? I think this is okay. There's going to be a load of types here eventually, and some of them are going to be like custom user-defined types, so we'll have to deal with that. But for now, it's quite simple. We can just say, what are we going to call these two things? Call them left-hand side and right-hand side. Is that okay? A new value is going to change from... So, okay, this shouldn't be called new value. This should be called... modifying value or something like that. Modify value, let's call it. Is that okay? It's a bit long. So... And I guess these should be called old value and modify value, really. We could maybe just call them O and M. And the point is, the new value is going to be the old value plus new value. And weirdly, that's the same for all of our types. And I notice it hasn't... Oh, no. It has. This is interesting. There are actually only two types. F64 and I32. So, those are the only cases we want to handle. And now they have different types because this needs to be... The return value of this needs to be itself a value. So what we're saying is we know how to add up I32s, and it returns an I32, and we know how to add up F64s, and it returns an F64, and we don't know how to do anything else. So we're going to return an error, but it's weird this, because this is an error that should never happen, because the type checking should have already checked. Now, where are we returning a similar error? Okay, so here's an example of an error. Very similar error, actually. Invalid types for... I guess it's also an operator? It's a mutation operator? So maybe we'll call it invalid types for operator. Wrapping this thing, and these are going to need to be OKs. Or is that, maybe I want to just return instead of, no, yeah, I don't think I just want this to be a return. Whoops, what on earth did I do there? So lose the bracket. Lose those OK wrappers I just put on. If the types match, we do something, otherwise we return something. And what it should return, it needs the error wrapper here. I forgot. And why is it complaining? Expected report. Well, I think I'm missing an into. Am I missing an into? Yes. Okay, good. So it's going to say, yeah, it's pointing at the operator that was wrong. So it's going to be talking about mutation token everywhere. It's talking about operator. And all of our mutation tokens are too wide, so this still works. Oh dear, that was not what I meant to do. So this hard-coded length here for the symbol is going to be okay. We should definitely have a test for this. We've gone way too far without writing a test. I noticed that times equals is not done at all. We've only done plus equals. And I noticed I'm going to want exactly the same error handling in the other case, which is going to make this quite verbose, and we might want to somehow share that code, but let's not worry about that yet. Let's first of all write a test for this. So where's our happy case test? Yep. Let's look at one of our error tests and do something similar. Oh no, there must be a test for the wrong operator type, right? No. Maybe because it shouldn't ever happen either. So let's do mutating an int with a float is an error. And that's, while we're here, let's double check that Rust really does this. So let's say that A is 50. And then instead of adding 2 to 50, let's add 2.0 to 50. Let's see what Rust says. Rust says, cannot add a sign float to integer. Okay, so it's actually a different error type, which is probably a good idea. All right, so our code is going to be let x equal 50, x plus equals 2.0. And there should be an error, and the error should say something, let's say something really similar. Cannot add a sign float to integer. Oops. Cannot add a sign float to integer. Now I think a lot of this is going to change, but let's just write it that way for now. And the code is going to be exactly this code. And it's going to point at this plus equals operator. Like so. And I don't know what that bottom bit's going to look like. None of this is going to look anything like this, so let's run it and see what happens. Alright, so okay, it unwraps with an OK and an I32. So that's surprising. Why? Also, the other thing changes. The other thing fails as well. Mutating a variable changes its value. Panics at missing name X. Because it's not called X. Let's call it instead of 13, because 13 is too long. But yeah, all right. So missing name X is actually a correct error message. Now it should fail, I guess, in the second half, which is, yeah, it doesn't know how to do times equals yet. Now back to mutating an int with a float is an error. Panicked because it actually didn't give us an error. So why didn't it give us an error? Well, we've got x plus equals 2.0. That should be passed as a float. Somehow it's not. Let's try just running this test, and then we'll see if we can get it to log out some errors, or some debug information rather. So when we evaluate a mutation, we've got two values, our old value and our modify value. So let's print those out, and hopefully we'll see the types of them. Oh, you know what? It's because no, I don't know. I suddenly thought it was because we're not type checking any of this stuff yet, but that shouldn't matter because this is like a kind of fail-safe type check we're doing in the evaluation phase. Where are we printing out our debug information? It feels like we're not getting into the mutation code because I don't see any debug information. Also, this is getting annoying with warnings, so let's just make these stop warning us for a second to make it easier for me to read what's going on. All right, so so this makes sense that we didn't even get to this code because otherwise it would have failed. So somehow it's not recognizing that this is a mutation. So it's not calling self mutation, which means it's not getting into this code, which means it's not calling this code, I guess, which it should be calling when it gets to the right operand of a mutation. But interesting. So at the moment we can only handle leaf tokens on the right hand side. So that's already a problem, which definitely needs fixing, but it still should work for this case because alright, so let's just print out some stuff in here and see whether we get here. What's the right hand side of our mutation in this case? Still not getting anything printed. We're just getting an I32 of 0 coming back. So it feels to me like so that means we're not getting to mutation right operand. Why not? So do we get to here? Maybe not, because it somehow thinks that we're doing an operator. Or maybe it... Alright, let's just see. So let's just see whether we get here. So this should be what? Mutation. Otherwise we get to here, which is operator, let's say. Now I'm really starting to wonder whether my debug printing is working at all. I think it should be, so I think it must be that we're not getting in here, which would make sense, like why isn't this working? So let's just check that we get to here. Let's just call this after the function. Yes, okay, we do get to leaf operation or mutation. Fine. And then the first thing is to check whether there is anything at all. Otherwise it was a leaf. So let's just check whether we get inside here as well. So I guess this is like some tokens. Like so. Yep, we do get some tokens. Fine. So I guess we should now start printing it every branch we get into. So if it was an end token, we'll quit out immediately there. Yes, okay, it was an end token. So, all right, so let's just remind ourselves what code we're running. This is in this test for an error. So I'm just wondering whether this is actually in the first step, but I guess it's... So what if we just say x plus equals 2.0? What happens then? We get missing name x. So we are, in that case, we are trying to evaluate. I'm pretty sure we're trying to evaluate. Let's check. So line 308. Oh, it's just this line here. Okay. We can check with the backtrace, I think. I want to check that we're getting to anywhere near my code. Oh, it's not going to... Okay, it's not going to tell us what I wanted to know. Okay. Forget that. So anyway, it looks to me like it's trying to evaluate this x. Maybe it's trying to evaluate a mutation operation. I guess it would be worth trying to figure that out, wouldn't it? So we can do that by logging if we just get into mutation. I think there's something wrong with our code that sees an X and then looks for another operation after it. Okay, it does get into mutation. It's after it's printed that sum token thing, it gets into mutation, it says missing name X. So I think that's doing approximately the right thing. And we want to, come on. So we need to put back our other code. Now, should it get to the same place? So it does, but it says that it gets to the end token. So I guess we should look for why it gets to end. Now where are we? Oh, it's in the parser. All right. So I think that where this is going wrong is in the parsing. Although, I mean, it is eventually going to get to end. So maybe this is fine. Just before we get to end, we also do some other stuff. So let's just see what other stuff there is. So let's go with like not end. Printf debugging is the way forward. Okay, never gets to not end. So it looks to me like it recognizes that this is a mutation. Well, it recognizes that there are more tokens. And I guess we should say, can we please print out what this token is? When we end. So when we end, the token is a semicolon at position 14. That feels quite far along. Where's 14? Oops, I'm in the wrong place. Should be looking at evaluator. So position 14 is this semicolon here. Oh, well, that's totally fair enough. So, yeah, it's evaluating the first statement, and it says there's either a leaf or an operator. Actually, it's just a leaf because I can tell because I hit a semicolon. The point is, I then want to start looking at this evaluation. That's where I go wrong. And we never get to anywhere interesting after that first statement is done with. Which is funny. So it does do the checking for a mutation the first time around. The second time around, it finds a symbol, and somehow that symbol is not parsing how we want. So, okay, what we should do is make this a test like this in the parsing code. So what have we got in the parsing code that tests a mutation? I'm guessing it doesn't test it after something else. Parse mutation just looks at this. So let's do parsing mutation after an assignment. Parse mutation after assignment. And I think that's where we're going to find our bug. Let's not call it ABC, let's call it AAA just for variation. And it should, well, it should come out as a mutation of AAA adding 33. But before that, there should be an assignment. So let's just find a test where we had an assignment. Looks like this. So it's going to be a list of an assignment and then a mutation. And the assignment is going to be of something called AAA, value of 3, type I32. Well, no, we didn't have a type, so this will be none, I guess. And it does have mute, so we're going to have true here. I think that's how that works, but we'll see. And obviously the positions of all the characters are going to be totally wrong. So 1, 2, 3, 4, 5, 6, 7, 8, 9. That's going to be at 9. And it's going to proceed for 3 characters. And our other positions are just going to be a nightmare, aren't they? Let's try out. So 10, 11, 12, 13, 14, 15. Makes sense that it's 2 further along. And then 15, 16, 17, 18. This is going to be at 18. We'll go for 3. And the plus equals is going to be at 22. Sure, I've got these wrong. 25. And this is going to be at 25. Like so. And, oh. And it's reasonably happy with it. So this parse mutation after assignment is the test we want to try out. Like so. And how has it parsed it? It's parsed it approximately right, I think. It's a syntax tree with an assignment at 8.3. What did I say? 9.3. All right. I reckon I've got to take 1 off everything now. I'll trust it that it's counting right and I was counting wrong. I was counting from 1. I think I should have been counting from 0. Okay, so that does parse correctly, which I guess is encouraging, but it does mean I still have no idea what's causing the bug. But it's so we can assume that it's parsed this as 2 statements. It gets to that second statement, and somehow then it goes wrong there. So when we're evaluating, we've done 1 statement. We're going to the next statement. We've just done an assignment. So, all right. So our next statement is going to be a mutation. So we should be printing out mutation. What do we print out? We never print out mutation. So it's not recognizing. Hold on. Yeah. So we got ourselves printing stuff out in the parser, which it's probably no use to us now because we think the parser's working. So get rid of that. And it never prints out mutation, but we're pretty sure. Oh no, I guess we're sure that this statement has been parsed, but we're not sure that it's been parsed as a mutation. So every time we get asked to evaluate anything, let's print it out and see what it says we're evaluating. All right, so there's a few things we've been asked to evaluate. It's not surprising. So first of all, I guess this is the assignment statement. Assignment. X equals 50. Then we've been asked to do it again. Then we've been asked to do just to evaluate the 50 part. And that's it. We've stopped without evaluating the second statement. So could that be because our debug code that does evaluation doesn't evaluate all the values? Or something else? So we've got these typed syntax trees. I guess we should have a look at what this typed syntax tree is. That might help us. It does look like it evaluates all of them. Oh no, wait. Are we not calling? Yeah, I think we're not calling this function in our error checking code. Is that right? Yeah, we're calling eval. And eval gives us an iterator, and we're only calling next once. Okay. We finally figured out why this thing isn't doing what we're expecting, which is it's not even evaluating this second statement. So how are we going to do this? I guess we want to call eval twice. No, sorry, call next twice. So let's call this we get back an iterator from eval, and the first thing shouldn't be an error, so we call next on the first thing. Let's just say first statement should not fail, and then the second one should fail. So I guess this needs to be mutable. This should, oh yeah, so I guess we're going to unwrap it to say there should be one, and then we're going to expect it to say the one we get back should not be an error. So this is, we could just say, given that we've wrapped onto multiple lines, we may as well make this more explicit. First statement should exist, and then it's kind of clear why we're unwrapping twice. Then this time we're going to unwrap error on that, so we're just saying definitely the second statement should exist, and then it should be an error. And now we are failing. We're printing out a load of rubbish, so let's stop printing out quite so much rubbish. And figure out why we're failing. I'm glad it wasn't a totally fundamental problem with my parser. It was just a problem with my test. Okay, so it is a mutation. And it is saying byte index 38 is out of bounds. So evaluator 177. I've obviously messed up something. This looks a bit wrong. like, why am I adding? I feel like the code I copied has an error in it, and I just copied it. Like, why are there two copies of operator.span.0 here? So I feel like I need a test which checks this code as well. What shall I do? Let's just put in a to-do here. To-do, this looks wrong. Test this error. Don't want to get too distracted with that this time, or we're never going to finish this video. All right, so. Okay, this is much better. We've now got an error message, much like what we expected, and because I didn't make a new error type just for this, the error message is not exactly what we want. So I think I am going to make a new error type for this. And I'm going to say invalid types for mutation. And it's going to be very, very similar to invalid types for operator. So I'll just copy it. Invalid types for mutation. And it's going to say, what's it going to say? Cannot add a sign float to integer is what I heard. So cannot something, something to something. It's going to be type 1 and type 2 or something like that. Type left to type right. I'll have to do for now. And then these are going to be cool. Those things here are going to be the things we mentioned. They're going to be properties here. And but how much we can fill those in is interesting, isn't it? So operator is like plus equals or something like that. So we don't need that. Okay, so now we need to make that actually do it. So we need some extra fields. So operator's going to be missing, but instead of that, it's going to be, we're going to want to change the mutation token into a string in some way. But so in other places, we allow ourselves to turn a type to a string already. And we don't actually implement it very well, but we will do sometimes. So the left-hand side is a symbol. So really we need to look up the symbol. Oh, we did. We looked up old value. So we can say old value dot like something about the type. And then new value, something about the type as well. So let's just, for now, we're going to say to do left, to do right, like so. And then I guess we can implement the mutation token, I guess that's not. Let's get something working. This would be mutation. And now maybe our test will look something like what it should look like. Cannot something to something. Cannot something to something. And this 19 is more correct than my test. And some of the rest looks okay. So let's change what we can. I think I'll leave commented out the like correct answer. Because we want that back at some point. So I'll put this just afterwards. So this should be, this is at position 19. And this is to do mutation, to do left, to do right. This is all just, if you've forgotten what we're doing, we're just trying to get it to write a decent error message when you try and add a float to an int. Okay, close, but not quite there. Okay, so here needs to move along a bit. We missed out on mute. So I don't know how that happened. And actually that causes it to move along, so that might be enough. So close, so close. I think it's pointing at the wrong place. No, it's that this, oh no, it's this. Okay. All right. So we've got it to print out an error message when you try adding a float to an int. Now I'm going to make it print an error message, check that it prints out an error message when you try and multiply a float by an int, let's say, just to get it the other way around. So imagine that x is 5.0 and we're trying to multiply by just 2. You shouldn't like that either. So this should be mutating a float with an int is an error. All right, in fact, why don't we just say multiplying? Multiplying a float by an int. And then the previous test we can call adding a float to an int. Can't spell. Adding a float to an int is an error. All right, so this one. Now this is not going to work yet because we haven't done the times equals part. Failed. Oh, we've got some debug statements left as well. Okay, that was the last one of those. So this is invalid types for mutation. And this was all in the plus equals case. So what about the times equals case? We want almost exactly the same code, which makes me nervous that we should somehow share it. But you know what they say, get it working and then make it good. All right, so I'm leaving a deliberate bug in here, which is that I'm adding when I should be multiplying. I think I also wanted to do to say share code will do. Previous case, share error code at least. But we won't fix that yet. Let's check that. Our error message looks about right. Yeah, it's pretty good. It's just moved along by 1. Yeah, so let's fix our test. Yeah. Later, Andy here. Apologies, I lost the audio from about the last 2 minutes of this, but I'll just try and talk over it here. So basically, we need to update the line of code that it's printing out in the error message so that it matches what we actually used in this test. Make sure that everything lines up, get rid of the extra semicolon, rerun the tests. They're almost right, but the stood in line should say 20 instead of 19. Run that test again. And we can see that all the error tests are now passing. So the error handling code is all right. So let's run the tests with, like in the non-error case. And we left a deliberate error in our code. The mutating a variable changes its value test checks that you can multiply 13 by 2 and get the answer 26. But we left in a plus instead of a times in our code. So let's go into our code and change that plus to a times. This is when we're times equaling something. Now when we run the tests, they all pass. So that's got all of our tests working. Now we're just checking back through which tests have been ignored. Couple that I'd forgotten we'd ignored that we might want to come back and fix. The one about while loops also ignored. But yeah, this complex expression thing we actually came across in this video. The previous one. But yeah, so that's the while loop condition whose condition is false is the one that we're probably going to work on next video, which is basically the first test of like while loops actually work. So we do a quick diff just to check what we changed this time and whether this is a suitable time to end the video. Basically, we've looked at we've basically made mutations work. Mutations being like times equal and plus equal. So here's the code that actually does all the work that makes those mutations work. It's almost all error handling code, which is kind of nasty. We haven't done the eval while, so the next video will be about actually getting while loops to work, because we had to do mutations first in order for our code that checks while loops to be valid. But here are some tests that we did write. We wrote these things about mutable assignments working, and then about multiplications working, and then about errors when multiplications and when mutations don't work. We also wrote this, as I said, this ignored test for while loops working, and we added an extra test for parsing a mutation after an assignment. It turned out it did work, so that was all okay. Okay, so basically we got times equal and plus equal to work, and I hope you're having a great day. See you next time.